So yesterday we had started with mean value theorems, and we have solved some of the problems, and that's more than enough. Okay, and some more things we will give you practice problems for that. Okay, more important is Taylor series. Okay, so that we will do it at the last of this, at the end. When we end, we will start with Taylor series. Okay, which is very important, whether you consider CFD, whether you consider finite element methods, whether you consider say even simple heat transfer. Okay, Taylor series becomes very important. Okay, so let us go further. Okay, so mean value theorem, yesterday we saw first theorem was Rolle's theorem, right? Rolle's theorem. What was Rolle's theorem? It says that if a particular function is continuous in the closed interval, okay, a and b, when you say a function, you have x and you have y here. Okay, y is equal to f of x. That's what a function means. It is if you have a function like this, suppose a function, okay, and in case between two things, between 2 points a and b, between closed interval a and b, it is continuous. Okay, continuous in a and b, continuous in closed interval ab, and differentiable in say open interval ab, then what happens is there is at least one point where f dash of c, at least one point where not just this, in addition to this, there should be f of a should be equal to f of b. In addition, f of a should be equal to f of b. If this exists, 1, 2, 3 conditions exist, then there exists at least one c where f dash of c is equal to 0. What do you mean by f dash of c being equal to 0? It means the slope is 0. Now the slope is 0 means it's parallel to x-axis. This is Rolle's theorem. If a function f of x is continuous in the closed interval ab, is differentiable in the open interval ab, and f of a is equal to f of b, then there exists at least one c where f dash of c is equal to 0. This is Rolle's theorem. Okay. Next is Lagrange's mean value theorem. Okay. Next one we saw is Lagrange mean value theorem. Lagrange mean value theorem. Actually, it is all one. Okay, it's not different. Okay, Lagrange mean value theorem says a bit more generalized. Okay, Rolle's theorem is specific, and when you come to Lagrange mean value theorem, it is a more generalized one compared to our Rolle's theorem. Now, what here it says is if f of x is continuous in closed interval ab, differentiable in open interval ab, that's what it says. It doesn't say f of a is equal to f of b. So function can be anything. Okay, I have 2 points over which it is continuous as well as differentiable. Okay, so there are 2 points here, say a and b. Okay, then there exists any one point, there exists x is equal to c such that there exists one x is equal to c such that f dash of c is equal to f of b minus f of a divided by b minus a. What does this imply is, see here, this point, this is f of x. Okay, this is f of x curve. Okay, this is y. This point is f of a, correct? And this point is, I'm sorry here, just a second. So let me write it neatly. Okay, sometimes I rush, and that rushing will create trouble. Okay, and this is f of b, correct? So now what does this particular thing imply? This implies that f of b minus f of a. What is f of b minus f of a? F of b minus f of a is this distance along the y-axis, is it not? What is b minus a? B minus a is along the x-axis. So what this particular thing shows? It is slope. So there will be at least one C where the slope is equal to the secant line joining these 2 points on the x-axis, or these 2 points on the curve f of ax. What are the points? B comma f of b and a comma f of a. So joining these 2 points, there is a secant line. So there is at least one point on the curve where the tangent will be parallel to the secant line. That is, there is at least, write this down students, what I am writing now, there is at least one point, geometrical meaning, okay, one point, okay, on the curve such that the slope of the tangent at that point, is equal to the slope of the secant line, joining a comma f of a and b comma f of b. I hope you get this point, students. Very, very important. This is the major crux of the theorem. Okay, all are mean value theorems only. Okay, so after this Lagrange mean value theorem, next we will go to Cauchy mean value theorem, and after we go to Cauchy mean value theorem, we will directly go to Taylor series. Okay, today we will start with Taylor series because mechanical and civil engineers, it's more important that we do Taylor series. This is also important, not that it's not important. Just because it is not asked till now doesn't mean it will not be asked next time. People had that problem. Okay, when we do gate coaching, we say these are more important, these are less important, like that. And some of the times what we have said it is less important has come for 4 marks. Okay, this happened in 2018 when I was taking for the first time. Okay, so I said gyroscope did not come till now. Gyroscope was a topic which did not come till then much. So I said you leave it. Okay, not very important. It may not come, I said. Okay, it has not come till now, but it came for 4 marks at that time. Okay, so it happens. So we have to be very careful about that. Sometimes the whole topic will not have anything. There was one particular paper where there was no question on convection at all. Okay, heat transfer meant radiation only. One small question on conduction and the whole radiation. So like that it will be there. Okay, so gate is very unpredictable. Okay, then people said cams won't come. Cams came. Okay, so don't be saying that it will not come. We cannot say anything. Okay, fine, students. Is that done? Have you written this down? Have you understood? Let us go further. I want authentication from your side, students.
Yes, sir.
Yes, very good. Okay. Next one, we will go with Cauchy mean value theorem. Okay. So we will see what is Cauchy mean value theorem. Cauchy's mean value theorem. Actually, this one is the most generalized one. Now here, let me write the thing, then let us understand the geometrical meaning of that. Let f of x and g of x, let f of x and g of x be two functions, let f of x and g of x be two functions which are both derivable or differentiable in which are both differentiable in open interval AB, not closed interval. It is given here, it is closed interval, no, open interval. Okay, two functions which are both derivable in open interval AB and continuous, very important. I don't know why did they miss that. Okay, continuous. Okay, if it is differentiable, it is continuous. We don't have to worry about it, right? The function which is differentiable has to be continuous. Okay, so when I say differentiable, it's enough. Okay, so differentiable in open interval AB, and g dash of x is not equal to 0 anywhere. Okay, for any value of x, for any value. So I'll use a closed interval here, students, as they have done it, because when you say closed interval differentiable, it is done. Okay, so it's continuous also. Okay, so g dash of x is equal to 0 for any value of x in closed interval AB, then there exists, okay, there exists at least one value, then there exists at least one value of C in between A and B, such that f of B minus f of A divided by g of B minus g of A is equal to f dash of C divided by g dash of C. Okay, students, the people who have prepared for JEE might know this already. Okay, this is not new to the people who have prepared for JEE. They might have gone to a bit more deeper in this, is it not? Anybody has gone for JEE, has tried JEE and not tried this particular one, mean value theorems? This is the basics, is it not? Yes, students. Tell me when you finish, then I will give you the geometrical meaning of this. Yeah, students, not over. Come on.
Yes,
Why?
sir.
Yes, fine. Why are you stopping like that? I give you time so that you. Yeah, please tell me. Okay, please be responsive. Okay. Now, what happens? What is the importance of this Cauchy mean value theorem? Is like this. Okay. So what happens is we have, instead of having xy as the coordinates, here we will have g of x and f of x as the coordinates. That's it. Okay. So any coordinates, x is another, this one, just like if we have say say enthalpy and entropy are both a function of time, temperature, is it not? So we can have enthalpy versus entropy curve, is it not? Enthalpy versus entropy in this side, right? We can have it, correct? So now similar way this is the case. Now it is similar to having say a point here and point here. What is this point? This point is f of x, g of x, correct? Or f of a, g of a. Let us put this as point A. I'm sorry. So this is point A, let me tell you. Okay. So this is point A, correct? And say this is point B. Fine. This is point B. So now I can have this point is given as A comma f of A, and this point is B comma f of B. That's it. Sorry, I'm sorry here. This would be g of A, or I can say, yeah, I can say this is g of A. A is in x, the other coordinate, okay, and this is g of B, and this would be g of A comma g f of A, and then this would be g of B comma f of B. Is it not, students? Correct. So now what happens? There would be one slope here. There would be one what? F dash of C by G dash of C. Correct. So what is this? This slope here would be F dash of C by G dash of C. Why? This slope here, observe here, this slope is what? F dash of C by G dash of C. That's it. That is what is the meaning of it. Okay. So it's the same slope. What would be this one? This would be f of b minus f of a divided by g of a by divided by g of b minus g of a, and that's what is written here. Simple, students. Understood where it is important? Please write this down. Okay. So that is what completes the mean value theorem, students. We don't have to worry much. Okay. I will give you some more questions as an exercise. I want you to solve this. Okay. So main thing is that generalization of the Cauchy, what do you say, our Cauchy mean value theorem is Lagrange mean value theorem. Sorry, a specific case of Cauchy mean value theorem is Lagrange mean value theorem. Specific case of Lagrange mean value theorem is Rolle's theorem. Okay, and one more side is all these things together are called mean value theorems. Sometimes when you say you apply mean value theorem, it means one of these three. Okay, yes, whichever is applicable. Okay, fine, students. Let us see now Taylor series, which is very important. And this has come a lot of times in GATE, number of times it has come. Almost alternate or 3 or 4 years it will come once. Okay, which is considered to be good frequency. Yeah, students, done it? Have you written this down? Have you understood?
Yes, sir.
Yes, very good. Okay. Now let us see Taylor series, which is very important, or Taylor's theorem, or we can call it also as generalized mean value theorem. Generalized mean value theorem. This is also mean value theorem only. Okay. Now, how does it happen? I will tell you tomorrow how to get Taylor series from Lagrange mean value theorems. Okay. Now let us take the Taylor's theorem as it is written. Taylor's theorem. Okay. I am using the words of Ramana. Okay. So let us see. Let f raised to n minus 1, that is f n minus 1, the n plus n minus 1th derivative, n minus 1th derivative derivative of f is continuous in closed interval a comma a plus h. Now saying a plus a into a plus h is equal to saying a comma b. B is a plus h. That's what it means. Okay. Now fn, okay, let fn minus 1, okay, is continuous in that particular, and again fn, that is nth derivative, fn, let it be like this, okay, fn saying that it is derivative, fn, the nth derivative exists in open interval a comma a plus h, and p, small p, be a given positive integer, It looks difficult, students, it is not integer. Then there exists at least one number theta, lying between 0 and 1, such that okay, our f of a plus h, things are much more non-complicated, students. Okay, let us know the most complicated one. Okay, then we will go to uncomplicated things. Okay, plus h into f dash of a divided by 1 or 1 factorial, I can say, plus h square by 2 factorial into f double dash of a, plus so on up till plus h raised to n minus 1. This is raised to n minus 1, students. Just a second, let me write it neatly. Plus h raised to n minus 1 divided by n minus 1 factor. I hope you can see this, students. N minus 1 factorial into f raised to n minus 1 of a, okay, plus Rn. What is Rn? I will write in the next slide. Okay. Why this is important also I will tell you, students. Done? Written down? Be responsive, students.
Yes, sir.
Yes, very good. Okay. Now this Rn is equal to, is given by h raised to n into 1 minus theta raised to n minus p, okay, divided by n minus 1 factorial into p into f raised to n, f of nth derivative of a plus theta h, okay, where 0 is less than theta is less than 1, okay, that means something into h, okay. So till here if you see, it was h only into consideration. This r1 was important, rn was important, right? Rn became this. Generally what happens, we ignore the higher order terms, we call it hot, HOT, higher order terms, okay. We neglect that. Generally in our engineering applications, we hardly take first degree or the second degree. Most of them we stop till second order. Third order if you take, it's great, okay. So whether you take finite difference or our finite volume methods, this Taylor series becomes the basis of that, okay. I would recommend, if a person is interested in pursuing CFD, there is one professor called Srinivasa Jayanti. He is a professor in chemical engineering department of IIT Madras, okay. You can take his NPTEL course. There is an NPTEL course by Professor Srinivasa Jayanti, okay. He is a fantastic teacher for CFD. If a person is interested in CFD, understanding CFD, go for this. And he starts from here. Why did I say this? Because it is related to Taylor series, okay. Whenever he starts, first he starts with basics of fluid dynamics, and then he says each of the terms in the Navier-Stokes equation, how it has to be discretized. Now what happens when you go with finite element methods? You generally discretize. What do you mean by discretize? You have to discretize the domain. We think that discretization is about discretizing the geometry. Yes, in fact it is. But the geometry is a part of a differential equation. If you understand the differential equation, you get to know that you are not just discretizing the domain, you are actually discretizing the differential equation. Okay, differential equation, which is complex, cannot be solved by your manual method. Okay, there is one, there is a any nonlinear equation. Okay, most of the nonlinear second order, third order nonlinear differential equations are unsolvable. Okay, if you are able to solve it analytically, then there is a 1 million prize being announced by Max Planck Institute in Germany. This was introduced in 1970s. Okay, so what they wanted is to solve the Navier-Stokes equation, because if you solve the Navier-Stokes equation, you solve the problem of turbulence, which is a great headache for everybody. Okay, so Navier-Stokes equation, if you can get the analytical formula, because we don't have analytical way of solving this, we have to go towards Taylor series methods. And through the Taylor series method, the ones which is dependent on Taylor series method is our finite difference method, finite element methods, and finite volume methods. These are methods to solve differential equations. Okay, and finite difference is used in solid mechanics as fluid mechanics. FEM is generally used in solid mechanics but also used in fluid mechanics. FVM, finite volume methods, is specifically used in heat transfer and heat transfer and this one, heat transfer and fluid mechanics. Okay, and one of the pioneers of this is Patankar. He is a Indian scientist. Okay, Patankar. Okay, what is the full form of Patankar? His surname is Patankar. Okay, Professor Patankar. Okay, he is very important person who has developed this FEM. Okay, just to tell you all the things which is important. Okay, fine, students, is that clear? Now here what happens, what is the value of P and theta? Depending on that, there are number of things, but I think we can ignore that, is it not? Okay, yes. Now let us have it. Okay, if in case, okay, let us say one by one here. Have you written this down, students? Okay, one more point. Okay, now this reminder Rn is called the Lagrange reminder. Okay, and this reminder, okay, if you put P is equal to N, if in Rn we put okay, not to worry, P is equal to N, okay, then what happens, the remainder Rn becomes equal to x raised to n, because the or h raised to n, okay. So it can be, okay, let us go further. Let me tell you, just a second. Not this way will not go, okay, because I wanted to skip something and I made a mistake here, okay. So now let us see one thing. We will not skip, okay. So if I consider the remainder term, if I go with Scholomilch, don't have to worry about this, okay, Scholomilch and Roche, according to these scientists, don't have to worry about this, students. You have to understand this is coming somehow. Don't have to remember this also. You can write this and forget, okay. Don't write on your, this is forgetting, okay. Don't remember these things, not important, okay. But it is important only to know that this kind of things exist, that's it, okay. It is 1 minus theta, don't get intimidated by this, it is not very important, okay. N minus P and f raised to n into a plus theta into h divided by n minus 1 into p, okay. Second one, if you take Cauchy, okay, if you take Cauchy, then we have p is equal to 1. Wherever p is there, we put 1. So what it reduces to is, it reduces to Rn is equal to h raised to n into 1 minus theta raised to n minus 1. P we are putting as 1, okay, divided by n minus 1, factorial is there, I am sorry I missed a factorial here, factorial, into Fn, that is nth derivative of a plus theta h, correct, that's it. Now why it is important, I will tell you, students, today and tomorrow both, okay. If you consider Lagrange, don't have to worry, students, about this. Again and again I will tell you, you have to write it, but okay, let it be there on your notes but not in your formula sheets, okay. Rn is equal to h raised to n by n factorial into f of n of a plus theta h. Easy. So these are the three things, okay. Now here, if in the Taylor series or in the Taylor's theorem, okay, if we put a plus h is equal, okay, please write this down, students, first of all, let you finish that. I give time to write because you have to think, students, okay. And it should go in a slow pace, only then you will understand. So tomorrow is the last class for mean value theorems, okay, and we will solve a lot of problems. Then we will go for maxima minima, very important, which is all simple, okay, very simple. Calculus now is going to simple phases. Next we will go to vector calculus, where you will see, actually feel the heat, okay. After this is over, then we will go for integration. After integration we will go for line integration, surface integrals, volume integrals, okay. So like that we will see. It becomes really complicated, but complication is for few time only, okay, until you know it. Once you know it, it's not complicated. And the way I will make you understand with the basics or with the applications, like you have applications of this in fluid mechanics, heat transfer, solid mechanics, you have applications. I will tell you the applications. Because I tell you the applications, your mathematics seems easy, okay. This I will give you a assurance, okay. I hope you have written down this, students, correct? Please respond, students.
Yes, sir.
Thank you very much, okay. So now here if I say, see what did I do here? We had f of a plus h was equal to f of a plus h into f dash of a divided by 1 factorial plus h square by 2 factorial into f double dash of a plus so on. Now here if we put a plus h is equal to x, if we put a plus h is equal to x and or h is equal to x minus a, x can be any value, right? A plus h is equal to x or h is equal to x minus a. If we put that in this equation which we have seen, Taylor's theorem, okay, what do we get as? We get f of x is equal to, I am ignoring the last terms, okay, not needed, okay, this becomes equal to f of a, okay, this becomes f of a because f of a only, plus x minus a, this is very very important students, what I am writing, very important, f dash of a, tomorrow we will do problems on this, divided by 1 factorial, okay, plus x minus a the whole square divided by into f double dash of a 2 factorial, f double dash of a 2 factorial and so on. At the end what you will get is, you will get plus, and then the remainder and all those things we will not worry, okay. So we have those things, we will not worry about that, it's enough, okay. So like this we go, okay. So another point here, okay. Now in this particular case, okay, if I put a is equal to 0, this is more than enough students, okay. If we put a is equal to 0, if you put a is equal to 0, then this is called Taylor series, student, this is called the Taylor series, very very important. This you can say 5 stars because it comes so much of times. If one more star is there, then not trouble, okay, you can have more stars here, okay. If we put a is equal to 0 in Taylor series, then we obtain Maclaurin series, which is given as f of x is equal to f of 0 plus x into f of 0 into x into f dash of 0 by 1 factorial, okay, f dash of 0 into 1 factorial plus x square by 2 factorial into f double dash of a plus x cube by 3 factorial into f triple dash of a and so on. This is called the Maclaurin series. It is nowhere related to the car, okay. You have a Maclaurin's car, is it not? It is nowhere related to this, okay. Maclaurin's series. As a mechanical engineers, you might be interested in all the formula cars, is it not? Series. What is this? This is Taylor series. Very 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 important. Both are important, students. This particular thing is very important. Reminder we will not see. We have a reminder here. We are ignoring that. That's not required. Okay. Let us see the question. Now here, once we do this, this is not enough. We have to see how it is applicable. Okay. Why it is applicable. We are ignoring the reminders here, okay. Tomorrow we will see how Taylor series can be got from the Lagrange mean value theorem. Why do we call it a mean value theorem? Okay. Today we will see what has come in GATE. Okay. Tell me when you finished writing, students. Understand. Yeah, done, students.
Yes, sir.
Yes, very good. Okay, now you may say no also. Okay, don't wait for me to okay, fine, leave it. Okay, so now let us see. Okay, uh, can we say determine the Maclaurin's series for you have f of x is equal to cos x. Okay, see here you can get an infinite series for that. That's the main thing. Okay, so what happens? F of x, Maclaurin series, how it is? F of x is equal to f of 0, correct, plus x into f of 0, correct, students? I'm writing the Maclaurin, I'll go slow, I'm sorry. Okay, plus x square by 2 factorial into f of 0, f dash of 0, I'm sorry, this is f dash of 0, this f double dash of 0, plus x cube by 3 factorial into f triple dash of 0, and so on, is it not? So what is f of x? F of x is cos x. Okay, that is equal to, what is cos x? Cos of 0 is 1 plus x into sine of 0. What is sine of 0? Sine, because cos, when you differentiate you get sine. Sine of 0 is 0, is it not, students? Plus here x square by 2 factorial, let it be there, x square by 2 factorial. Fine. What you get? F double dash of 0. What is f double dash of 0? Minus of cos x. Correct. So this will come as minus. Okay. So why this has happened? So let me write it here. Okay. So cos of 0 is equal to 1. Correct. F of cos of 0 is equal to f of d of dx of cos x at x is equal to 0 is what? At x is equal to 0 is 0, is it not? Because it's sine. Similar way, d square by dx of cos x at x is equal to 0 is equal to minus 1. So like that it goes. Plus here when you say third time it will go to 0. Then what you get? X power 4 by 4 factorial you get. So what is the cos infinite series, students? It is 1 plus x is 1 minus x square by 2 factorial plus x power 4 by 4 factorial. Correct? Are you getting that point, students? So like that it goes. Fine. Am I correct here? So what you get at the end is this way, minus x power 6 by 6 factorial. This is the infinite series for cos x. This is the answer. So if you forget the infinite series, students, okay, you can directly go to Maclaurin series and find the series. Okay, is that clear? Now do one thing, find sin x, find e power x. Can we do that, students? Simple. Find the series e power x through Maclaurin series. Okay, then tan x probably. Okay, you can find it out. Correct? Easy. Saw the importance of Maclaurin series, students. Okay, tomorrow we will see about Taylor series, its importance. Okay, write this down. We will do some realistic examples and then we will see, which has come in lot of times in other things. Okay, in GATE as well as other places it is important. Okay. Tell me when you finish it off. Okay. Tell me, calculate sin x series also afterwards, and e power x also. Okay, I will tell you that. Now let us see one second. Let us understand how do we get that. Okay, let us understand what is the importance of this Maclaurin series directly. Okay, for example, now let us say that sin x. Let us calculate sin x. Okay, sin x through Maclaurin series I will get is as x minus x cube by 3 factorial plus x power 5 by 5 factorial plus minus x power 7 by 7 factorial and so on. This is what is sin x is. Okay, so what does that mean? It means like this, students. Okay, so if I have, say, what I am doing approximation. Keep that in mind. Sin x will be equal to sin x when it goes to infinite series, infinite. Okay, so what does that mean? Let us see. Okay, and it is at 0, very important, it's at 0, correct? So now if I curtail over here, if I curtail the point over here, then what happens? Okay, sin x is equal to x. What is the x? 1. It is like this. It means it gives the first slope. Okay, it gives the slope of the line. Okay, it is slope here. Okay, so that is first side. Now in addition, if I take, for example, say actually if y is equal to sin x goes like this, students. Okay, it goes something, this is 45 degrees, it should be. Okay, so sin x is something like this, correct? This is sin x. When approximation happens, okay, when the approximation happens, sorry, my writing is very poor. Okay, when the approximation happens, first approximation approximates it as a line. First approximation approximates it as a line at 0. That is the approximation. It's not right. Okay, this is the actual y is equal to f of x. Okay, now if I take till here, what is this? If I take that, if I stop till here, then this will be equal to x minus x cube by 6, right? So now if I take, how is x cube by 6, if I see, it will be something like this, students. Okay, it will go like this. It will come here and then go down like this. This would be x cube by 6 function. Okay, it will go directly like this. This is x minus x cube by 6 function. This is the function. If I add some more, for example, if I add y is equal to the third term till here, x power 5, if I take, okay, so if I take x power 5, then what happens? It comes like this. Okay, let me use the other ink. Okay, okay, if I use x power 5, then it goes this way, then it goes like this, and then this way. Okay, and this goes down here it goes like this, it goes this way, and then it goes like this. This would be y is equal to x minus x cube by 6 plus x power 5 by 120. So you see, as you add more and more terms, this becomes closer, the curve becomes closer and closer to sin x. I hope you get the point. And sin x is the most complicated curve, student. Let me tell you, it's not that easy. It's the most non-linear term. Okay, that's why if you have sine term in a differential equation on the dependent variable, it's a real headache. It's real headache. Okay, like if you talk about, say, forced vibrations, or there is something called there is something called fluid structure interaction. If you consider that, there is something called fluid structure interaction. In that you have sinusoidal impact, or sinusoidal forces being there, okay, because of vortex shedding. All those things is okay, but still I'm telling you where it is important. Okay, it's very difficult to handle these kind of things. Okay, yeah, students, so we will stop the class now. Any doubts you can ask me. Tomorrow we will go with much depth and more of Taylor series and problems. Okay, then we will go with our after Taylor series is over, we will go to maxima minima, which is very easy. Lollipop questions come there. Do not miss those things. This is also very easy. Okay, what we are doing, Maclaurin series, Taylor series, all the mean value theorems are very easy, and whenever it comes in GATE, it comes direct. Do not miss these things. Okay, it comes not very frequently like limit or continuity, but when it comes, it's easy. Okay, don't miss that. Okay, thank you, students. Any doubts here?